Good afternoon, my name is Ramiro Serrano and I'm going to talk about FM radio transmitters. In telecommunications, there are two important signals involved to establish a correct communication system: the carrier wave and the modulated signal. To transmit analogic signals, the carrier wave can be modulated by using either amplitude modulation, frequency modulation, or phase modulations. An FM transmission is the process to encode data using a modulated signal, which keeps constant its amplitude, but its frequency could change depending on the variation in the amplitude of the modulated wave. In the picture uh, shows an example of FM modulation. In the picture shown above, we have a basic tank circuit. In here we can see an inductor on the left and a capacitor on the right. The blue arrows show the current direction and the moment. So here we have that the capacitor is discharging electrons through the inductor. That current is going to build a magnetic field on the coil that it's going to keep growing up until the capacitor stops discharging. Once this happens, the magnetic field is going to collapse and is going to send electrons to the capacitor, but in the opposite direction that the capacitor send electrons. So we are going to end up having a capacitor charged but polarized differently. Once the capacitor is done charging, it's going to discharge again through the coil, but like we said before, it's going to be polarized differently than at the beginning. So it's going to build a different magnetic field with different polarity, with the opposite polarity than it was first. And again, this magnetic field is going to keep growing up until the capacitor is done discharging, and then it's going to collapse and it's going to discharge to the capacitor in the opposite polarity and charging the capacitor in a different polarity. So it's gonna keep flipping every single time this process. Okay, so in order to get the differential equation for the tank circuit, we are gonna use Kirchhoff's voltage law, KVL to summarize, around the loop. So we end up with voltage in the inductor plus the voltage in the capacitor equals 0. This can be expanded by saying that the voltage in the inductor is L multiplied by the derivative of I by the time, plus the voltage in the capacitor is going to be 1 divided by C multiplied by integral of I dt equals 0. This KVL equation contains an integral, which is awkward to deal with. So we are going to derive both sides of the equation and end up with a second grade derivative for multiplied by L with 1 divided by C multiplied by I. And this is going to equal 0. And that's how we get a second grade derivative equation for this tank circuit. Most common applications for tank circuits is tuning radios, transmitters and receivers. But LC circuits behave as electronic resonators, which are key components in many applications, like amplifiers, oscillators, filters, tuners, graphic tablets, and even electronics related to surveillance. The reason why we need oscillator tank circuits for FM transmitters is because the FM transmitters require a radio frequency carrier waves, and the oscillator tank circuit is the one that carries that job. By having a modular capacitor, we're able to change the resonating frequency in that